Hello, welcome to this lecture video. So we're going to talk about the assumptions in linear regression. So what are the different assumptions of linear regression? So we have the following. So first, linearity. So we already checked for linearity using the scatter diagram. So it can be that there is a positive or negative relationship. In case that you can see that the relationship is not either positive or negative linear correlation. So you have, of course, to consider if you will still use the test. Next, you have to check for independence of errors. So errors is computed by computing for the residuals. And then next, you will also check for the normality of errors. And lastly, you will check for equal variance or homoscedasticity. So the acronym for the assumption is the line. Okay, so how to check for that? First, if we will use the manual computation for residual, the computation of the residual is the difference between the observed value and the predicted value. And for the linearity, so we check for linearity by just making or by just using the scatter diagram, the original data, if you can find for the relationship. For independence, you will also use the scattered diagram, but you're going to use the residuals. And there is an independence when there is no relationship or there is no pattern in our scattered diagram. While for normality, we do have several tests actually in testing for normality, or you can also use the normality line test generated using the Microsoft Excel. So these are some of the formula that can be used to compute for normality, but we're not going to use that. And then for equal variance or homoscedasticity, we're going again to consider the inspection of residual scatter diagram. Okay, so how to do that? So we are going to use our original data. This is our data. And we will generate the regression using the data analysis. So just click data analysis, regression, and click OK. So it is, let's select our Y values, our X values, and then you can just check residuals, normal probability plots, residual plots, and line fit plots, and just click OK. So this is now our regression result. So we have here the initial requirements or preliminary analysis for you before you will use or before you will report that you're confident that there is really a linear relationship, or if you're going to continue to use the linear regression as part of your analysis. So line, again, L stands for line. So if we will come up with a scattered diagram using our data, so we actually generated this before we use our data. So this is our scattered plot for line. And it seems that there is a relationship, particularly positive relation. So let us place here. So linearity. So check. Next. I is independence of errors. So to check for independence of errors, let's go back here. We will use the residual. So since there is no patterns in the residual, or you can actually come up with the residual using this. But anyway, it's already generated, so we're going to use for the generated graph or chart. So errors, control V. So there's no pattern. It means that there is independence of errors. Next, letter N is normality of errors. We have here x variable or line fit flat. So if our points or the predicted value now follows the line of our y, as you can see here, it's a very near it. Or in our normal probability plot, we can also make use of this. So if you can see that it forms a line, just like here, if I'll draw a line here, so it forms a line, it means that the data is normally distributed. So we will consider this. It forms a line, it means it is normally distributed. Or you can use other normality tests if you want to verify if the data is really normal. So line, independence of errors, normality of errors, and the last one is equal variance or homoscedasticity. So for equal variance, so to check for that, we will use the same plot, this one. So just to show you, let's consider a paint just to show you the line that I am talking about is that if we're going to draw a line here, so it's not scattered. So it seems that it's just within that line, so it means that there is an equal variances assumed. While if I used another graph, like for example, just to show you that this one, let's consider this. Assuming that this is the graph, so the line here is, assuming that this is the line, this is just an assumption. Assuming that this is the residual plot, look at this. If I'll draw a line here, and a line somewhere here just to get all the data, it will still exist. So which means there is no equal variances. Or let's see, for example, if this is the line that we are referring to, just like this, it's the distance from our x-axis is increasing until this part. So which means there is no equal variance. So let's go back. So as mentioned, we will consider the same graph or chart. So let us summarize. So the data met the following assumptions. So it is linear. It forms a positive correlation. It has independence of errors because the scattered diagram or the scattered plot of our residual plot do not form a pattern. While for normal probability plot, so it forms a line, it is normal. And then for variable, so there is an equal variance because as we draw lines here, all the points are within that line. Okay. So I also provided here a summary just to show you what's the difference with no pattern. There is a pattern. So as mentioned, for linearity, there should be a relationship such as it's a positive or negative. For independence of error, so this is no pattern. This is an example that there is a pattern, so it's a U shape. And for normality of error, it forms a line. So if your graph, for example, is this one, then it means that it doesn't form a line. So the normality of error is violated. For equal variance or homoscedasticity again, so if we're going to draw line here, so that no pattern in the scattered diagram of errors. While here, there is a pattern again, so it's a U shape. So that's for the assumption. So what you need to do is to check first for the assumption before using the linear regression model. Thank you for